to talk about GraphQL. And the reason why I'm going to talk about it is because it sort of came out in the QP and in the brainstorming session that we did a few weeks ago. It was kind of vague and we didn't know what it was about, but we were talking about it. So I thought it'd be a good idea at some point to do a presentation, and then I forgot and I remembered today, so here we are. I did do I wanted to build the API for a personal project I was working on at the end of last year, and I tried GraphQL, so I'm by no means an expert. It worked out very badly at the end. It wasn't such a good implementation, but I did pick up some things and I want to share that with you. So first of all, GraphQL is an interface definition or description, pick one, language, right? So it's a language that you use to define how two applications talk to each other. It's an application level protocol. You essentially define data types and actions that you can perform on those data types. Some of the other IDLs you might know are Swagger, Thrift, and Protobuf. If you don't know, Swagger is something that Jonas did some work on before he left, and then I tried to implement it in Hedwig, and it didn't work out very well. Swagger is a specification for REST APIs, for REST interfaces, and Thrift and Protobuf are designed by Facebook and Google respectively, and they're designed for efficiency. So you've got two services running inside a data center talking to each other, so you might as well just use a binary protocol, something very fast without a lot of checks. Whereas Swagger is designed, and GraphQL as well, are designed to for communication between the client and the server through HTTP, through the global wide web, so to speak. And GraphQL is designed to optimize on the number of requests and the size of the request payload and the response payload. So it actually reduces that size to one request, and then the size of the response is as minimal as it can get. And we'll see about that later. So why is it called GraphQL and how it works? The idea is that you, as an API designer, you design your interface, you model your data as a graph. So you define nodes and types for those nodes or vertices or whatever you want to call them, and then you define paths between nodes, edges in your graph. And querying this data model is equivalent to traversing the graph. So you start from a data node, you grab all the data that you want from that, you move to the next node, and so on and so forth until you grab everything that the client requires, package that into some sort of a response, and send it back down the wire. We'll see how that works. I wanted to go through a simple example just to kind of see how that works, and I didn't want to pick the canonical example of just a to-do list because I think it's too easy. So I went with something that is also easy, but a bit more, not as easy as a to-do list. So what we want to do now is put ourselves in the shoes of a single-page front-end developer that's trying to build this blog post page. So it's trying to call the API to render this page. And we're going to see how to do that with how that is done in like strict REST, and how you do it with GraphQL, and how you would model the data set of a blog engine with GraphQL API there. So what we see here is I pretty much chunked a blog post page. You've got information about the author, you've got some stuff about the content of the blog post, you've got a nice title and a header image, and then some comments with some information about the users that posted those comments. Those are kind of modeled directly to the graph sort of paradigm, right? So you've got one type in your graph is user, right? So you've got multiple vertices that are of type user. One of them is this guy. You've got multiple vertices in your graph that are of type blog post. One of them is this one, right? The relationship between this user and this blog post, this user created this blog post. So you can essentially navigate, when you query, you can navigate from this user to this blog post and fetch the data from there. The same is true for responses or comments, right? Comments are created by users and they're sort of attached to this blog post. We'll see how that kind of works. So in GraphQL, you just have a single request to the server. Of course, the query is all the magic, where all the magic happens. But in REST, you would have something like this. So imagine that you're starting with just the ID of the blog post, right? You're writing your JavaScript application, you've got the ID of the blog post, and you need to populate this data. So first you're going to get the blog post information, the blog post resource, and based on that, you would fetch the resource for the user and all the comments and maybe all the followers if you want to cheat a little. Now, what you would normally do if you were like a REST purist, you would get all these comments, and for each of these comments, you would do an HTTP request to get information about the user, whether the user follows the author or not, and all that. This is the classical N+1 problem, and all the abstractions on top of relational database have to face. It certainly translates to REST. Cool. So how does the GraphQL query look like? Remember that I said it's like a graph traversal. So you start with a user and you have to specify the ID. This guy in this context created 2 blog posts. We're only interested in the first one. So you're going to get some data about the user, and then we're going to request just the blog post with the ID 1. We're going to get some data from that specific node. So imagine that this node of type post is like an object that has attributes and things like that. And we're only interested in the title, body, header, and date. It could have multiple other things. From that, we're interested in actually getting all the comments. Now you could paginate that. For this example, I'm just interested in all the comments, and right now there are just 2. It's this one, this is a 1, so it's a comment with ID 1 and a comment with ID 2. This is created by user 2, and this is created by user 3. And only user 3 is following user 1. Okay, so I'm getting all the comments, so this is going to be a list of comments. From each comment type, I'm only getting this fields, and for each comment, I'm getting the user of that comment, and I'm only interested in this thing. So the query is pretty self-explanatory. The result is also very similar to the query, except for the attributes that actually return arrays. In this case, comments is going to be an array of objects with this format. That's pretty much it. As a front-end developer, you get this large JSON, and you can populate all your templates to render that page in one HTTP request. That's sort of the advantage. I mentioned before that GraphQL is a language, is a DSL that you use to write the schema. And the schema looks like this. You define the types that each node has to have, so it's not, again, it's a language, it's an abstraction, there's no implementation here. You define the types that each node has to have, and then you've got these 2 very sort of interesting and special types that GraphQL parsers expect from you. This is the query and the mutation. And there's a new one that's the subscription. And what happened, so the query is the first node in the graph traversal. Here, we start from the user. We cannot start from any other node because we specifically told the parser and the query resolver that you always have to start from the user. So you use this mechanism to restrict the nodes from which a client can start traversing the node, so to speak. And then the mutation, as far as I got with it, is just a flat list of functions that you do to that graph. If you want to sort of create a user, you create a new node of type user, you have to provide some data. In this case, I only need the email. This is another example, but it doesn't matter. And what's interesting is that mutations also work as queries. So mutations return a type from which you can query further. So you can say, I'm creating a blog post, that's returning a post. But the post has a link to the user. And from there, I can say, okay, I want the email of that user, or I want all the other blog posts of that user, or I want all the comments that the user created. So, and also what you can do is you can have multiple mutations in this chain. And both these things can easily be done on the same endpoint. You don't need a tree of your farm, just one. Not that this is an advantage, but this is how it goes. Okay. Cool. So far I've spoken about how it works and what kind of advantages and where it positions against other solutions, but I think it has a lot of disadvantages and I personally don't like it very much. So first of all, it increases complexity. I used Go to implement my server, and it's quite difficult to parse something like this in a statically typed language. So you could see GraphQL as moving complexity from the client side to the server side. But in fact, even the client side becomes more complex, because if you want to aggregate all the data that your application needs, you have to have a sort of a collector of requests from all your components and all your logic in your front end. So that's kind of challenging. There are ways to do it in React. I don't know what they're called. Okay, so that's one thing. It's harder to do. It's also much harder to design. This model of a graph is very flexible because it has no restrictions. I mean, you could model any sort of data field in graphs in a million ways. There are no restrictions. But on the other hand, it's very hard to design, especially very hard to design it so that's future-proof in a way. You might find yourself a few years later that you designed your edges and your vertices such that they don't no longer support the functions that you need to do. It's kind of hard to change. And also a big question is, how do you translate this graph traversal query into the data storage that you actually have on your server? In my case, I tried with SQL, and it's horrible. People like the guys at Facebook and the companies are using specialized graph databases, but essentially storing and retrieving data, graph data, is not very efficient. Certainly not as efficient